This is your first lab on measurement and density. First, we're going to learn about the measurement. For example, let's say we have to, this is the bar, and we want to find out the mass of this bar in grams. And this is the gram scale. So we can see that the mass of this bar is between 3 and 4. So that means all we have to concentrate on this part, 3 and 4. So what we're going to do, we're going to find the values of lowercase n, lowercase m, lowercase u, uppercase m, uppercase u, and add these values to get the measurement. So what I'm going to do, just this part between 3 and 4, I am going to draw it here. So this is my major mark 3, this is my another major mark 4, and in between there are 9 marks, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, so n, so the first one is n represents the last major mark. The last major mark is 3. So again, we are looking only between 3 and 4. So the bar has crossed the major mark 3. So n is 3. Lowercase m represents the last minor mark. So in between these marks, let me show you with a different color pen. Well, okay. In between these small marks are known as the minor marks, like these ones. These are known as the minor marks. So which minor mark this bar has crossed? So let's count. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going too far. So let me erase this line and show you again. So here, 1, 2, 3, 4, 5, 6. So it has crossed the 6th major mark. I hope you can see it here. So basically, this one is the 6th major mark. So my m value is 6. Now my u is the imaginary mark, and imaginary mark basically means that what you have to do is, so I know, so 5, 6, so I know the bar has crossed that 6th one, it's somewhere here. Then assume between two minor marks there are 10 marks, and then pick the one that you feel is closest to the imaginary. So between my 6th and 7th mark, if I'm dividing it into 10 parts, and let's say my mark is here, I'm going to pick the imaginary number like as 7. I mean, some students can pick 5, some can pick 8, but that will be fine, because measurement, your last digit is an approximation. So one more time here, so these are my major marks, 3 and 4. These 10 in between, 1, 2, 3, 4, 5, 6, 7, 8, 9 are the minor marks, and then in between any two minor marks we assume another 10 marks, and that we call it as an imaginary mark. So for this one, let's see if I can make it bigger. For this one, I picked my imaginary mark as 8, because if I'm looking at these 2 points here and here and thinking about 10 in between, it looks more to me more than 5. So I picked 7, sorry. So that was 7. Now how do you calculate m? M is the range of n, or I like to go with this, high value minus low value divided by the spaces in between. Again, you are looking at just here. So this 4 is the high value, 3 is the low value, high value minus low value divided by spaces between. Spaces are not the minor marks. Spaces are not these marks. Spaces are, these are known as spaces. So how many spaces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 minor marks basically create 10 spaces. So 4 minus 3 is 1. 1 over 10 is 0.1. That's my m. And how do you find out u? U is m over 10. That means 0.1 over 10, and that will be 0.01. So the final answer will be n plus mm plus uu plus minus u. So my n is 3, mm 6 times 0.1 is 0.6, and uu 7 times 0.01 is 0.07. So 3 plus 0.6 plus 0.07 will give 3.67, and then you say plus minus 0.01, because again keep in mind that my last digit is an estimate. So plus minus 0.01 means for this measurement you can have your answer between 3.66 to 3.68. So that's my final answer. So in your lab 1 quiz, this will be your question number 1. Here is the centimeter scale, and you have to find out what the measurement is. So let's do more practice. So in this one here, so let's say this is a milliliter scale. So if it's a milliliter scale, that means my volume is milliliter. So again, if you look, the length is between 3 and 4. So that's all I have to worry about. So my last major mark is 3. Lowercase m represents the minor mark. These in between, these small ones are known as minor marks, and it has already crossed the minor mark, the third one. So there are 1, 2, 3, 4. So if I look, it has already crossed the third minor mark. So here, so that means my m is 3. Now what I have to do is, this u is my imaginary mark, so I can see that the milliliter is the unit for volume. So if I have, here is my 3, here is my 4, and there are 1, 2, 3, 4 minor marks, and it has already crossed this one, the third minor mark. Now in between this minor mark and this, I'm going to assume 10 imaginary marks, and just pick the number, and I decided to pick 4. Now what will be uppercase m? Uppercase m is the range, which is 4 minus 3, divided by the spaces. How many spaces are there? 1, 2, 3, 4, 5. 4 minus 3 is 1. 1 over 5 is 0.2. So my m is 0.2. And what will be u? U is m over 10, which is 0.2 over 10 equals 0.02. Then my formula is n plus mm plus uu plus minus u. N is 3 mm, lowercase m times uppercase m. So 3 times 0.2 gives 0.6. Then 4 times 0.02 gives 0.08. When I add these numbers, I will get 3.68 plus minus u, which is 0.02. So again, what does that mean? Plus minus 0.02. If I subtract, I'm getting 3.66. If I add, I'm getting 3.70. That means for this measurement, if the students are reporting any number between 3.66 to 3.70, that will be correct. So this is the centigrade scale temperature, and so you have to do the same thing, find the measurement, and that will be your lab 1 quiz question number 2. The next is the determination of the density of a regular shaped solid. So let's assume we have this wooden block. So first you're going to measure the length of, this is the ruler. So you're going to measure the length of this block and write down here. You're going to measure the width of this block and write down here, following the measurement rules, the one I explained on the last 2 slides. So here, for example, if it is here at this point, this is between, let me clear this here. And so it is, if you look at the length, so length is between 1 and 2. Look at the minor major marks, find out the length of this block here, find the width of the block here, and write it down. Make sure you're writing the correct number of decimal places. There should be 2. I'm already providing you the height. So then using length, width, and height, you're going to find the volume of the block. Then I'm providing you the mass, and then you will calculate density, which is mass over volume. Here I have given you one example. It has nothing to do with your numbers, but it is just an example. So let's say there is another block and the length, width, and height are these. So you're multiplying them to get the volume. And remember, this length, width, and height are your measurements. So if you are multiplying them, you're applying the significant figure rules to represent your answer. So length has 3 sig fig, width has 3, height has 3. So whatever number you are getting by multiplying, you have to report the answer to 3 sig figs. Then the mass is given to you, and then you will calculate density by mass over volume. And again, let's say this is your mass, which has 5 significant figures. Your volume has 3 significant figures, so that means your answer should have 3. So you're going to solve this and find the density here, and then that is your lab 1 quiz question number 5. Now your question number 3 and 4, are based on this experiment, which is known as the finding the density of an irregular shaped object following water displacement method. And if you really want to know what this method is, you can click here and watch the video to see how this method is used to measure the density. In this one, what we do is we take a graduated cylinder and fill that graduated cylinder halfway with water, and then we read the level. This is the level here, and you always read the lower meniscus. And I read it following the instructions that I gave in my first slide. So the level is between 10 and 20, and then 10 is the last major mark, and you calculate U, M, everything, and I found it as 19.1. Then what we did, we took this metal sample, and the mass of this metal sample is given to you, 27.371. Had you been doing in the lab, then you measure it using the weighing machine. And then when you place this metal sample into the graduated cylinder, the level of the water will rise. Now what you have to do is you have to read this level, and that goes here. So the level of the water is changed because you place the metal. So how will you find the volume of metal? That will be final minus initial volume. So make sure you follow significant subtraction rules. Now I have mass here. I can calculate density, which will be mass over volume. That means again, I'm going to look at my significant figures in the mass. I'm going to look at the significant figures in the volume, and I'm going to represent my answer with correct significant figures, and that will be here. And that will be your question number 3. What is the density of the metal? Once you found the density of the metal, what you have to do is you have to compare your density with the different metal densities given here. So let's assume your answer, you will never get the exact answer. You can, but in reality, when you're doing the experiment in the lab, due to so many possible errors, you don't get the exact value, the one given in the literature. You just get the closest one. So let's assume you did that and your answer comes out, let's say 7.49. Then which is the closest one based on this 7.49? That will be iron. So you're going to calculate it, you're going to pick the closest one, and that will be your question number 4.